Okay. So, and since I already told the little line before I turn that on, I got to tell those folks too. Yeah. See, I take my COVID test. I turn around. I can smell the espresso. I'm a happy man. All right. Now, for you guys, test Monday, a week from today. Don't worry about calculator parts because we're not doing that. Because if we learn how to do it by hand, and we learn how to do it correctly without a calculator, then we'll know how to make our calculators work. And that's where we make mistakes, when y'all start trying to do it without with a calculator, and you don't know anything about the without a calculator part. Now, today we're going to look at solving. That's all we're going to look at is solving, because that's a big part of this. So, I got 3 examples on the board waiting on you. Just a single log, all by its little lonesome. All right? Don't try to write down all 3 of them. I just wrote those down so I remember them. Okay? Working. Okay. When you have just a log by itself like that, the easiest way to do it is to use Rule 5. And that is to put a big old 7 here and a 7 here. That is not how your chemistry teacher does it, but on the very next step, she's going to write that. And she doesn't do this. She doesn't put the 7 there and the 7 there. She just skips straight to here. But that's how she got there. All right? That's how your chemistry and your physics teacher got there. Now, once you get there, it's just good old math from 51 and x equals 7. Now, x equals 7. Fair enough? All right. Now, there's something we need to do when we solve these log equations. We need to always test and make sure it doesn't have us taking the log of a negative number right here. I talked to y'all about that the other day, but we only know how, at this moment in time, to take the log of positive numbers right here. Okay? So always test your numbers. If you put 7 back in there, are you going to have a positive right there? Everybody agree if you put 7 back there? If you put 7 right there, I know why y'all are laughing at me. I'm on film when I'm doing this wrong. 17? Okay, 17. Yeah, if you put 17 back in there, you have a positive, right? Yeah. Everybody agree when you put 17 back in there, you have a positive? That's important to check. It's not that the answer down here is negative. It's whether when you put the number back in up here, it will make a positive. Everybody hearing that? Okay. I'll give you a little example. This is a key example we'll give you. Key concept. We'll use that big word. Concept. All right. Let's say I had log of 4 minus x. And after I worked it out, I got x equals negative 10 and x equals 2. One of those is wrong. Which one's wrong? Oh, be very careful. See that negative 10? What's 4 minus a negative 10? And 4 plus 10 is what? 14. That's okay. It's not, that's good. That's an okay answer. It's not that the negative sign is here. It's that it makes you have a negative when you test it back in the original. Is everybody hearing that? Now, see the 2? If you put 2 in there, yeah, oh, that's a good one. Let's try 6. Put 6 in there. What happens when you put 6 in there? You get a what? Negative. Can't use that one. Can't use that one. Now, the ACT test does this all the time where they'll have a negative answer down here, but it works when you test it. But what are they checking to see? They're checking to see if you learn the whole rule. It's not that the x is negative, it's whether it makes it negative when you put it back into the original. All right? And where do you have to substitute it back in to test it? The original. Do you have to work it all the way out? No, you just got to make sure it's not going to have you taking the log of a what? Negative. All right. Now, I sometimes forget to teach that. Yes, you can take the log of negative numbers, but not now. We're not doing it. All right, this one. What makes this problem different than anything you've worked? This is brand new for you today. You've got two logs on one side of the equation. Okay? Bad. Anytime you have two logs on one side of the equation, you're going to use rule 6 or 7 to make it one log. You can't have two logs on one side of the equation. You need that just to be one log. So what rule, since that's a -7, we're going to use rule 7. And we're going to, yes, we're going to divide. So we'll get log base 5 of x equals log base 5 of 2x plus 3 over 2x minus 3. Now, hey, we're going to go back and use the same thing that we did right here, right? Yeah, we're going to use rule 5. Now, when you do that, you're going to put a 5 here and a 5 here. So that's the inverse function's right there, leaves just an x. And this is going to leave 2x plus 3 over 2x minus 3. Now, please, you cannot use rule 5 if there's more than one log on each side. You cannot use rule 5 if you have 2 or 3 logs on one side. Everybody hear that? You must have just how many logs? 1 in order to use rule 5. There are going to be people who take the test on Monday. They're going to put a 5 here, a 5 here, and a 5 here. Are they doing the same thing to both sides if they put a 5 here and a 5 here, but they only put one 5 over here? No, they're not. See, you got to have just one log. For the people that do that, I'm going to laugh and you're going to fail. Okay, I'm going to multiply by the common denominator, so I'm going to get 2x squared minus 3x equals 2x plus 3. Anytime you see an x squared, you have to make it equal 0 and factor. And if you cannot factor, you didn't get in this class. Don't tell me you can't factor. I'll probably miss it after saying that. And we get x equals -1/2 and x equals 3. Now sometimes both of them work. Sometimes neither one of them work. Then it's an empty set. Okay? -1/2. It'd make you take the log of a negative right there, wouldn't it? See? Put the -1/2 there. I'm going to give y'all a chance to write a little bit. I see a lot of people writing. Make sure everybody's happy with where we're at. Yeah. I get to go a little too fast. All right. If you put a 3 here, that's going to be positive, that's going to be positive, that's going to be positive. So the 3 is a good answer. The -1/2 will not work right there, will it? Okay. Just so you'll know, extraneous, can't spell it, extraneous solution. That's what those are called. When that they won't work in your particular problem. Okay? Now, I will tell you this. If you had already taken trig and an upper level math class or two, you would find out that that does work, but you're going to get I's in your answers. All right? And we don't want that yet. All right? We don't want those I's. Okay. So far, so good. Ask me a question. I'm going to point. You ask the question. No, I'm not going to ask those multiple level questions. I'm just going to point. If you got a question somewhere, you're going to tell me. All right. Everyone probably already knows what we got to do in here. We got to do what to these two logs? Yeah, got to put them together. Make one log. So we're going to use rule number 7 again. I don't know why I picked 2 of them in a row that have rule number 7. So we're going to log base 5 of 4x over 6 equals 2. Somebody says, why don't we reduce that? I agree with you. Log base 5, 2/3 x there equals 2. What are you about to do? You're about to put a what below each one of them? 5. And here's what makes this a little bit different than the last one. You notice here you put a 5 below a log and you put a 5 below a log, right? This one you don't. This one's just going to leave 2x plus 3. 2x divided by 3 equals 25. So I've covered all, these two are the new stuff that you haven't seen before. And you get what? X equals, what do y'all work that out to be? X equals, that's not a rhetorical question. I want an answer. 3 times 25. So we get 75 over 2. And folks, you don't have to work out an exact value. You just got to know that when you put it right there, that's positive, isn't it? You put it over right there. Does everybody agree to be positive? Yeah. So that's a good answer. We're happy people. All right.
Is that a 2 under 75?
Yes, sir. It is.
Okay, so on number 2, you move, can you explain that step right there?
From here to here?
Yeah.
Okay. I see I got log base 5x. So I'm going to put a 5 there to get rid of it.
Okay.
But whatever I do on this side, I've got to do on the other side. And notice it sets it up perfect because 5 log base 5 of u is just the u. 5 log base 5 of that x is just the what? X. Now over here what makes it different is when I put the 5 here, I also have to put 1 there. But notice there's no log over there, right? So there's no inverse function. There's no rule. So that's just 5 squared is 25. That's the reason I work one where there's a log on both sides and one where there's not a log on the right. Which goes back to this. See number 3 over there? When you get down close to the end, it's like this. Is that good?
Yeah.
All right. Now, I'm going to work a few problems from the assignment that you're going to be working on. And when I do it, we're only working the ones that are circled, because I think I've already told you that I'm going through the book and I'm picking out everything we can work without a calculator. I'm going to publish this. And that way y'all can see it on your phone or on your calculator, whatever you need to. But you'll notice they're circled. Okay? We're only working the ones that are circled out of this. This is Sisson 5.5, and we're working everything that's circled. Now, I'm going to go ahead and work number 20. I'm going to work number 20 for you guys. I got to keep a list of which ones I work, otherwise I mess up later in the day. I'll work number 20. All right, number 20. (81 raised to the x). Can y'all read it, or you need me to? And then it's 3 raised to the 2x plus 16. Okay. If y'all don't mind, I'll never remember where those came from. Okay, here we go. Number 20. Doing good, folks. Sitting there and you're writing and you're listening. You're doing what you're supposed to do. We've been learning this way for a couple thousand years. Maybe not quite a couple thousand. I write, you write. I talk, you listen. And then I answer questions every once in a while. And this is 5 in Sisson. Number 20. 81 raised to the x equals 3 raised to 2x plus 16. As soon as you see this, what must you do? Say it loud. Everybody help her out and say it loud. Say it one more time. I'm glad y'all aren't at a rock concert because the guy on stage would just fall out sleeping. What? Very good. Or if you were a Marine drill instructor, it'd be yelling at you too Okay, that's 3 to the 4th. And if you don't know your powers, I need to go back and talk to your Algebra 2 teacher and have her adjust your grade. Okay, once the bases are the same, to be honest, you're using one of the log rules, but you don't need to know that. If the bases are equal, then the exponents would have to be what? Equal, right? Okay? So, you get 4x equals 2x plus 16, 2x equals 16, x equals 8. Now, you know how to test those if they don't have a logarithm in them. Make the bases the same. All right. That takes care of, let's go down to number 40. Number 40. Notice I'm not really fooling with these ones. It says make the bases the same up there. Look at number 40. Number 40. Before I look at 40, you sure there's no question on this one? Anyone? All right. And please, when you're working on this tomorrow, because you know tomorrow's going to be a work day on this, right? It'll be the lab day. Rework 20 and 40. And then if you can't work them tomorrow, you know, fresh, seeing them tomorrow, you got notes to go back and look at, right? Okay? That's how you do that. Okay. Log x minus 2 plus log x plus 2 equals 2. All right. You know you're going to combine those two logs, right? Yeah. Everybody agree? That's the first thing you got to do is combine those two logs. You must get down to just one log on each side at most. No more than one. Log. Multiply those together and you get x squared minus 4. I went ahead and just multiply them together on the same step. Is that okay?
So is that like, so could you
Yeah, pull it.
Could you do it 7, rule 7, and then just, or?
That's what I did. I did rule 7.
Okay.
Or rule 6. Yeah, I multiplied them together.
Okay.
Tell you what, let me do this. Man's got a question, I'm going to write it out. X minus 2, x plus 2. I multiplied those together.
So like, what, could you use rule 7 now?
Rule 7, but that's a minus sign.
Oh, so that's, okay.
Yeah. Rules, yeah. You got rules, the minus sign, you have to put them as division. Plus sign, you have to put them. And when you FOIL this out, folks, x squared minus 4. I hate the word FOIL. I can't believe I'm using the word FOIL on a broadcast that's going to be on YouTube. FOIL is a 4-letter word. It is not a math word. I really used what? Distributive property. I really used distributive property. Now, here's where I'm going to ask for a little help. What number is understood to be right there? 10. 10. Thank you. Thank you. So you put a 10 there. You put a 10 there, and you get x squared minus 4 equals 100. X squared minus 4 equals 100. X squared minus 104 equals 0. Or you could do what? X squared equals 104. I like that better anyway. That way, x squared equals what? 104. So x equals the positive or the negative square root of 104. Now folks, if you leave the square root of 104, it's not pretty, it's not aesthetically pleasing, but technically it's right. But it lacks that aesthetic quality. Ma'am? Oh, I thought you were telling me to reduce that. Yeah, that's what I did. I did square root of 26 times 4. And what is the square root of 4? 2. 2 square roots of 26. And now, let's be honest.
So do you want us to break it down on the test like that?
I want it to look like that. I want it to look really pretty. Now, let's be honest. Do y'all realize the negative square root will not work here? Do you have to actually work it out? No, you know a negative minus that is going to still be what? Negative. So the negative square root doesn't work, so the only thing I need is the what? Positive square root. All right? Oh no, because the minus won't work. The minus is not going to work because the minus that 2 is going to be a negative. We can't use it. All right? Okay, I want to go back and work 36. And 36, I got to work 36. 36. Here we go. The only reason I want to work 36 is to stress of something that you already are supposed to know. 36. 3 log base 8 of 512 raised to the x squared equals 36. Folks, see that 3? That's in a bad spot. You can either put it back up here and make that 3x squared, or you can simply do what? Divide this side by 3 and divide this side by 3. You can do it either way. If you follow the log rule, move 3 back up here, rule 4 in reverse, or just divide both sides by 3. See, that's the easy way to do it. Just divide both sides by what? 3. Now, you know that you don't like having that log base 8, do you? So how are you going to get rid of that? You're going to use one of your log rules. You're going to use the one that we used right here, where we put a 10 there, aren't you? Except you're not going to put a 10 there, you're going to put in 8. 8, 8. And 512 raised to the x squared equals 8 to the 12. I bet you 512 is 8 raised to some power, or at least 2 raised to some power. Okay, 2 to the what?
Isn't it 8 to the 10 power?
8 times 8 is 64. Multiply another 8 times that. Yes, ma'am. Yeah. So she said that's 8 to the what? Third. So that's going to be 8 to the 3x squared equals 8 to the 12. X squared equals 4. 3x squared equals 12. X squared is going to equal 4. I'll write it over here. And I'm going to get x equals a positive 2, or x equals a what? Negative. And guess what? You can use either one of them, can't you? If you put a negative 2 there, you're still going to be taking the log of a positive number, aren't you? And if you put a positive 2 there, you're still going to be taking the log of a what? Positive number. So in that case, they both work. Now, what I want you to do is to work only the ones that are circled. And you're going to notice a pretty long list. You're going to have the rest of today and all day Tuesday to do this section right here. And it's 2 pages, but I know it's already on there. And yeah, right there, see? And notice log equation. Everything, you notice how this is using everything that you've learned up to this point? Yeah. Today, in order to work these, you have to use every rule that we've learned. That's what we're trying to do here. Make you realize that all those rules matter. All right, I'm going to leave that up there. We'll try that again. Simon. I love it when the computer does it. Okay, I do not read the Wall Street Journal. And most people that I know that claim to read the Wall Street Journal really don't. They look at the pictures. You know, some people can read the Wall Street Journal, and the rest of us just look at the pictures. But I did see the article this morning while I was waiting to get my espresso at Rhino Coffee. Going to do another little plug here, Rhino Coffee. And just so you'll know, friends do not let friends drink Starbucks. Friends do not let friends drink Starbucks. Rhino, local. Okay, now, had something else funny I was going to tell you about all that. I don't now, really. All right, I'm going to let y'all get started on those. I'm going to probably download this video